Welcome, welcome. AP video 3.5 here, looking at empirical formulas. That is the main objective, to be able to calculate the empirical formula from percent by mass or experimental data. Turn off those phones, turn off the social media, pause, rewind as needed, and take some notes in the margin should you need to. Alright, so title's a little off here, but empirical formula, molecular formula. So let's start with molecular formula. The molecular formula is the actual chemical formula of a compound. So for example, right here we have glucose. Here we have benzene, hydrogen peroxide, water. Those are the chemical formulas of those substances, their actual formula. We can sometimes simplify it down to an empirical formula, which is the simplest whole number ratio of that compound. So for example here, benzene, if we divide all elements by 6, we end up with C6. If you multiply it by 6 there on the outside, that would get back into molecular. So this is right here is the empirical formula. Glucose, C6H12O6, is all divisible by 2, and its simplest ratio is CH2O. Hydrogen peroxide simplifies down to HO. And water can't be simplified, it's already in its simplest form, so what you're noticing here is that they are both the same. So in our notes there, I believe you can say it is possible that both of these two things can be the same. The molecular and empirical formula can be the same. Alright? Big idea here is that we're using percent by mass data, and we're going to turn that into an empirical formula here in a little bit. And eventually in the next video, you'll learn how to turn empirical formulas into molecular formulas. Okay, so that's the big idea. Percent by mass into empirical, then into molecular. So let's do a little practice problem here. And we're going to complete this simultaneously with notes while we actually do the problem. So here's the question. It has been experimentally determined that a compound contains the following. So this is the percent by mass data. This here would come from a mass spectrometer perhaps. And it could tell you what percent we have of each element. Now, to determine the empirical formula, here are the rules you want to do. The first rule you want to do is convert percent into grams, and also add this in your notes. Assume 100 grams. So if you have 100 grams of your compound, and it's 38.67% carbon, really that means you have that exact same number of grams of carbon in 100 grams. So we can write this down. 38.67% carbon. Oh, grams, my bad. That's how many grams of carbon we have. We have 16.22 grams of hydrogen, and we have 45.11 grams of nitrogen. And that's how much we have in 100 grams of the substance. So it's like a little trick. You assume you have 100 grams, these percents become the gram amount in 100 grams. The next step, number 2, is to convert grams to moles. So we all know to do that. So we got our grams of carbon here. Let's get that into moles. So it's going to be grams on the bottom, mole on top. And remember, this is called molar mass, a conversion factor here. So we have 1 mole of carbon weighs 12.01 grams of carbon. Grams cancel, we're into moles, and here we end up with an answer of 3.20. 3.220. That's how many moles of carbon we have. Now apply the same two to these as well. And I want you to unpause to see the answer when you're done. Try to do these two on your own quick. Alright, good. So now that you've done these two, this is how many moles of hydrogen you have, 16.06, and 3.220 moles of nitrogen. Alright, once we're into mole form, we want to get this into the smallest whole number ratio, and the way you do that is by dividing by the smallest mole amount. So, if you want to maybe add this to your notes here, gets to simplest ratio. Hopefully. Gets to simplest ratio. Alright. So when you look at these, the smallest mole numbers, actually, these are both the same here. Oftentimes they're not going to be exactly the same as each other here, but 3.22 is the smallest for all these. So we take all those and divide them by 3.220. And obviously for the first one, we end up with 1 mole of carbon. We end up with 4.988 moles of hydrogen. And we end up with 1 mole of nitrogen. And from that, as you can see here, this is pretty darn close to the whole number of 5, so we're going to round that to 5. And from this we can actually write the chemical formula now. So we don't need to apply this step here. We'll come back to that one second. So right from this we can write down our formula CH5N. So it's C1H5N1, just like that. And that would be our empirical formula we got from percent composition data up here and converted into this right here. Now let's just say these numbers here did not come out to whole numbers. So what you want to do then is multiply all of them by some number to turn them into whole numbers. So I said this earlier was close up to 5, we can round it to it. Whenever these numbers come out to really close to a half, let's say they've been like 4.5, how do we make halves become whole? You multiply them by 2. And the other option you might run into is if it came out to something like a third or 2/3. So if you had something like 2.34 or maybe 5.65, both of those are very close to being thirds, and the way you get thirds to become whole numbers is you multiply them by 3. And you'll see that in the next video for that. Alright, so that was a little video on trying to find the empirical formula from percent composition.